Welcome to a session on indices and logs. So to start with, I need to give you a preamble of this topic. So indices are also known as exponents or powers that are used to represent itself, a number by itself. For instance, if you're looking for numbers like a to the power b, a is a base, b is a power, or it's called an index. So there are a few properties that you need to understand about indices. To start with, if you power any number to 0, it is going to be 1. Even if it's a letter, if you power it to 0, it will be 1. Number 2, if you power any number to 1, it is itself. So a to the power 1 is a, 5 to the power 1 is 5. You get that number itself. Then if you're multiplying indices like a to the power m, a to the power n, as long as you're multiplying these, you're going to add the indices. You're going to add the powers. So a to the power m times a to the power n, it will be a to the power m plus n. All right. So for instance, if we have a to the power 2 plus a to the power 3, we're simply going to have a to the power 2 plus 3, or 2 a to the power 5. On the other hand, if you have a to the power m in brackets, there's another n outside. You multiply the powers. So m and n will multiply. Okay, so what am I saying? Just to illustrate what I'm saying, if you have a to the power 2 times a to the power 3, this is going to be a to the power 2 plus 3, which is going to be a to the power 5. However, if you have a to the power 2 divided by a to the power 3, this division sign becomes subtraction. So you're going to have a to the power 2 minus 1, 2 minus 3, which is equal to a to the power negative 1. If you have a to the power 2, then in brackets, there's another 3 this side. This means that you're going to multiply the powers. So this is 2 times 3. So this is going to be a to the power 6. These are the properties of the indices. Are we following? So
Yes.
if you have a to the power 2 plus a to the power 3, please, you don't make a mistake of adding them on top. A to the power 2 plus 3. This is not correct. You do them individually. So for instance, you have 2 to the power 2 plus 2 to the power 3. You evaluate them individually. So 2 to the power 2 is 4. Plus 2 to the power 3 is 8. So you get a 12. But if you have 2 to the power 2 times 2 to the power 3, you can just add the powers there, which you're going to have as 2 to the power 5, which will ultimately give you what? 32. So these are the properties that I'm trying to enumerate that you understand. All right.
I have a question.
Yes, please.
So this is only applying to if you only have the same bases, or you can
Yes,
have
it's
different.
only applicable to the same bases. Exactly. Very good question. If you're only dealing with the same bases.
Okay.
So it also follows that if you have a to the power negative m, if you want to leave it to a positive index, it's the same as a to the power m. So 2 to the power 3 is negative, the same as what? 1 over 2 to the power 3, which will give you 1 over 8. I hope you know that 2 to the power 3 is the same as 2 times what? 2 times
2
times 2,
times.
which is 8. All right. So indices sometimes are manipulated. For instance, we know that you need to at least have some 0, 1, 2, 3, 4. Some idea of numbers that are easily multiplyable. You need to have this table at your fingertips. They only ask you maybe up to 5 or so. So 2 to the power 0 is what? A number to the power 0 is what? 1. 2 to the power 2? 2. 2 to the power 2 to the power 1 is 2. 2 to the power 2 is 4. Right? 2 to the power 3 is 8. 2 to the power 4 is 16. 2 to the power 5 is 32. We go to 3. Any number to the power 0 is 1. So here 1, 4 to the power 1, 5 to the power 1. So 3 to the power 1 is 3. 3 to the power 2 is 9. 3 to the power 3, 27. 3 to the power 4 is 81. 3 to the power 5 is 243. 4 to the power 1 is 4. 5 to the power 1 is 5. 4 to the power 2, 16. 5 to the power 2, 25. 4 to the power 3, 64. 5 to the power 3 is 125. So these numbers are just important for you to know at your fingertips because of what I'm going to explain later on. 4 to the power 4, 256. 4 to the power 5 on your calculator. What is 4 to the power 5? Check on your calculator. I'm just using my head.
1024.
1024.
1024.
Like this. About 5 to the power 4.
625.
2.5, good. Then what is 5 to the power 5?
3125.
125. Okay. Now, if you have this table drawn, then all questions to do with indices will be very easy for you. For instance, finding the values of x. They'll bring a number, for instance, 2 to the power x is equal to 8. What's the value of 8? So just look at 2. Which number is equivalent to 8? This one. So this is the same as 2 to the power 3. So if you want, you can say 2 to the power x is equal to 2 to the power 3. Whenever the bases are the same, just cancel them. So what is the value of x? The value of x is 3. You can see this. So the exponent there that we're getting is the value of x, which is 3. Are you seeing what I'm doing? So sometimes they'll manipulate. They'll say 5 to the power x is equal to 1/25. Then you go in here. In the 5s, which one is equal to 25? This one there. But this is 1/. Remember from the power, we understood that 1/, means negative power. So you can do this 5 to the power x, and maybe this is 5 to the power 2. So just do 5 to the power -2. So when you cancel this and that, we're going to get x is equal to what? -2. So you need to manipulate your mind as well to a way that it will help you utilize this table. So sometimes they'll bring a question to say x to the power 2 is equal to 9. Now we don't know this base here. So you can check any numbers that are equal to 9. So here, this is 9. So what is this 9? It is 3 to the power 2. So obviously this should be 3 to the power 2, which is giving us 9. So meaning our x here is what? 3. So you need to think very much outside the box for you to understand how indices work. All right. So indices can also be used to come up with what we call quadratic equations. In our quadratic equations, you will find situations where we have 2x squared, then here -4 is equal to 0. Then maybe here we're going to have minus 2x. So in this question here, using quadratic equations, you know the value of x is equal to what? Negative b plus minus b squared minus 4ac over 2a. So quadratic equation follows the format x squared plus c is equal to 0. So what is our a? It is a 2, right? What is our b? It is negative 2. What is our c? It's negative 4. All right? So when you substitute it in here, where there is b, you put negative 2. All right? So negative 2 squared minus 4ac. So here we're going to have 2a. Where there's a, we put what? A 2. Are you following what's happening here?
Yes.
So you're going to have 2 plus minus. In this case, we're going to have a what? A 4 plus 8, 30. That is 8 times 4, 32. Then here we're going to have a what? A 4. So it's a quadratic equations where we're going to have 2 plus minus square root of 36 over 4. So I'm just taking you through quadratic equations so that you understand what is yet ahead of you. So 2 plus minus, the square root of 36 is what? 6. We divide by 4. So value of x will be what? 2 minus 6 over 4, which is negative 4 over 4, will give you a 1, negative. Or here we're going to have 2 plus 6 over 4. So this will be 8 over what? 4. We get a 2. All right. So this is a quadratic equation. Now, how can this question come in terms of a quadratic equation? They'll manipulate your question. Instead of writing that, to say 2 to the power 5x squared, okay, minus 2 to the power 5x, okay, minus what? Minus 4 is equal to 0. In this case, you need to create your own key. You can say, let what? 5 to the power x be what? Letter y or letter x, if you want. But where there is 5 to the power x, you put x. 5 to the power x, you put x, then it becomes a quadratic equation like this one here. Then when you solve the value of x, if it's 2 or negative 1, this is a point where you now solve. For instance, here, since we found the value of x as 2, you just do this, 5 to the power x, and here you put a 2. All right? Now, let me make mention to say that it's not always that you always have something found in here. You may have a situation where you have maybe 5 to the power x. Here is supposed to have 25. This one is obvious. What you're going to do here, you're going to say 5 to the power x, then here is same as 5 to the power 2. So here this cancels there. So meaning your x automatically is equal to what? Is equal to 2. But suppose I asked you to find 5 to the power x is equal to what? To 10. There's no number that is equal to 10 there. So what you're supposed to do is to introduce logs. You just say log 5 to the power x here is equal to log 10. Introduce logs on both sides. So only the log is what will cause you to drop this x there. So the x will drop here. We're going to have log what? Log 5. Here you're going to have log 10. So to find the value of x, you need to divide both sides by what? By log 5. So here when you divide by log 5, and here you divide by log 5, what we're going to have is x is equal to log 10 over log 5. What are you getting? Log 10 over log 5. What do we get? It's a decimal.
1.16.
1.16. Correct. But even in this case, can I introduce logs to get a 2? Yes. So in this case, if you don't know how to use your mind properly in that table, you can just say, I introduce a log. So log 5 to the power x here is equal to log what? 25. So what happens to this log here? It will drop there. X log 5 is equal to log 25. So how do we find the value of x? We divide both sides by logs. So here it will be log 25 over logs 5. Let's see if we're going to find a 2. Divide log 25 over log 5. What are you getting? It should be a 2.
1.55.
Log 25 divided by log 5.
Log.
Don't forget the log.
Yes, 1.55.
That's the power 2. It's supposed to be exactly 2. I hope you're not forgetting. Punch it again.
Log 25.
Divided by log.
9.
Not divided by 5.
Log 5. Log 5.
Yes.
Yes, 1.55.
1.55. How about log 8 divided by log 2?
1.442.
1.42. Then there's something wrong on your calculator. What calculator are you using?
Cash.
Log 25 divided by log 5. My calculator is giving me exactly 2. I hope you're not forgetting the log on the. I don't know what mistake you're making. Log 25 divided by log 5. You know where the log is? You're using a Casio? What calculator are you using?
Cash.
Okay. Maybe you need to confirm where you are. Let me show you the calculator. Oh, that's what calculator looks like. I hope it's the same one with yours. So if you're using a Casio calculator, it should look something like this. Just a minute. So, okay, depending on the versions, one and the same thing, but at least it should have the following features. So must look something like that, isn't it? Do you have something like this?
No.
You don't have something like this. So the log is somewhere here. The log is somewhere there. Is that the log you're using? The log should be somewhere there.
Yes.
So you press
Yes.
log 25 divided by log 5, then you press equals. You try that.
Log. There are 2 logs on my calculator.
Yeah. So you punch literally log 25 divided by log 5 equals. What are you getting?
Still same.
Okay, so then you do press mod. So understanding how the logs operate will now help us actualize the questions that will come in your exam. So let's look at the question that came. Part B, we want to solve this equation. And let's calculate value of x. So we've been given this question here. So let's substitute. We'll let x be 5 to the power x. Let's substitute in there. So can you see that?
No, I'm behind. What am I supposed to do?
So we're substituting where there's 5 to the power x, we're going to put letter x. So we use a quadratic equation. So here, we're going to rewrite this one here. This will be 5 to the power x. Then we put like a 2 outside, right? Then here it will be minus 26, 5 to the power x. Okay, plus 25. All right, so now I want to introduce the value of letter x. So upon where there's 5 to the power x, we put x. The quadratic equation will be what? X to the power 2 minus 26x plus what? 25. Remember,
25.
it was 0. So what is our A, what is our B, and what is our C? Our A is 1. Our B is what?
Negative 26.
And our C is what?
25.
25, correct. All right, so when you solve this simultaneous equation, we're going to find that x is equal to 1 and x is equal to 25. So now, since we had let x to the power 5 to be x, so we now go back here. So we found our value. If you want, you can solve this equation at your own time. You'll find the same answers I found. Remember, our question is what? X squared minus 26x plus 25 is equal to what? 0.
Yeah.
So our A was 1, our B was 26, and our C was what? 25. And we let x be what? 5 to the power x, right? Remember this. So here, our x will be what? Negative b plus minus what? B squared. Remember the quadratic equation, right? 4ac over what? 2a. Okay. So here, we're going to have what? Negative 26 plus minus 26 squared minus 4a c 25 over 2a. So what is 26 squared?
676.
676. Then what is 4 times 25?
100.
100, correct. So in short, the value of x here will be, we're going to find 25, and the value of x will be 1. So in this case, since our x was equal to 5 to the power x, so we're going to substitute here. Where there's x, we put what? 25 is equal to 5 to the power x. And where there's x here, we put what? 1 to find 5 to the power x. Remember, I said, how do we find the value of x? You can use logs. So find the value of x here. What do we do? I know the answer is supposed to be 2. But I told you that if you're not sure, you use logs. So if x is equal to 5 to the power x, and here x is 25, what do? We introduce logs on both sides. So here log 25 is equal to log what? 5 to the power x. So what happens to this? When it comes here, it will drop. Then you divide both sides by log 5. So here log 5 and here log 5. So what becomes our x? What is log 25 divided by log 5?
2.
It is 2. So this is how this question was supposed to be answered. You need to understand the logs. All right. So lastly, we do this, then we go to hypothesis testing. So I'm going to take you to part C now. Given that 2 log x base 2 is equal to y, and 2x base 2 is equal to y plus 4. Find the value of x. So this is another way in which logs can be manipulated. Now, part of the rules for logs that I needed you to understand and the application are as follows, because these are important for your assimilation. So when you're dealing with logs, you must understand that logs are read by their bases. So if we have log b base a, here our a is a base, our x is the exponent. So b is a result of the properties. So what we mean by this is that if you have a scenario where we have log 2 power 8 is equal to 3, this means log 8 base 2 is equal to 3. So what happens is, to force this to be an exponent, it will be 8 should be equal to what? 2 to the power 3. It comes from the basic rule which says you have a, b, c. So how do you remove the logs? A is equal to what? B to the power c. So this b will come and push this to come out there. So you need to memorize this format. So sometimes they'll give you a question where you'll be required to evaluate, for instance, 3x minus 2 base 3 to the power 2. So what happens is this 3 to push the 2 on top. So do you have x minus 2 is equal to what? 3 to the power 2. So what happens the other side? Our 3 to the power 2 can be evaluated as 9. So how do we find the value of x? We're going to add 9 plus what? 2 to get 11. So this is how we evaluate this function. All right, together?
Yes.
So logs occur in a very peculiar manner. If you have log 3 base 2 plus log a base 2 is equal to 3. So you can factorize this. The base 2 is common throughout, and you're going to have 3. The addition becomes multiplication. The a will be here. Then here we're going to have a 3. So here to be, this will push the number there. We're going to have 3a is equal to 2 to the power 3. So 3a is equal to 8. So to find the value of a, we divide both sides by 3, and our a will be 8 over 3. That's how logs operate. In a different scenario, we could have the same scenario, base 3, but here the sign is what? Minus a to the power 2. Then here we have 4. So in like manner, you can factor out a 2, then this is 3 divided by a. The minus becomes a division. So we have 2 to the power 4. Oh, here we have 4 before it makes a power. So to push this one, it will push it on the other side. So it will be 3 over a is equal to 2 to the power 4. So 3 over a is equal to what? 16. So here, our a will be 3 over 16. So this is how we evaluate. So quickly go to our exam question scenario where we're given 2 evaluations here. Now, before I go to these 2 evaluations, lastly, there's another property which says if you have 2 log 4, this one will come and climb on top of this one. It's the same as what? Maybe if you have a 3 there, it's equal to x. So this one will climb on top of this one. So this will be log what? 4 to the power 2, then the 3 will be a base. And we know that 4 to the power 2 is 8. So you're going to have 8, 3 is equal to what? X. So how do we evaluate this side? The 8 will remain, then this 3 will be the power x. Then you can evaluate using logs if you want. You can evaluate the answers. So when there's a number this side, when it comes this side, you can square. So these are other rules of logs. So in this case, log x base 2, then there's a 2 there. So what will happen with these 2? It will climb on top. It's equal to y. So we want to find the value of x. This is 4 marks. So let's evaluate first. Log x base 2 is equal to y. So we have 2 functions there. I think this is my last question before we go to hypothesis testing. So here we have x base 2 is equal to y. Then the other equation we're given is what? Log 2x base 2 is equal to y plus 4. So let's use the rules of so how do we expand this, Lisa? What happens to these 2? It will climb on top. We're going to have what? X squared, then base 2 there is equal to what? Y. Right? Then this, to remove the log, it will be expanded as follows. X squared will be 2 to the power y. Are you together so far? Are you following what has happened? These 2 came on top there to come here. Then this came to push the y on top to come there. So this is what we have here as equation 1. Are we together on equation 1?
Yes.
Then here again, we use the rules. What happens here? 2x is equal to what? 2 to the power y plus 4. All right? Are we together? Are we together?
Yes.
One comes to push that there. All right. Now, if this is x to the power 2, to remove the x there, we can simplify the value of x there to be what? X. To get rid of this 2, we can just do 1 over half times 1 over half. So meaning here, the value of x here will be 2 to the power y over 2. So now if this is the value of x, we'll put it where there's x here. So here you're going to have 2. Then here you're going to have 2 to the power y over 2. Then this is going to be 2 to the power y plus 4. So in this case, we want to solve for y. So we need to have a similar base. So the question is, are we able to multiply this by that? So this is to the power 1. What did we say? If the base is the same, you add the powers. So this is 2. And this is 1 plus y over 2. And this one is 2 y plus 4. So if the bases are the same, we can cancel there now. Then what do we have there? 1 plus y over 2 is equal to y plus 4. So we need to solve for y. All right. So you put the like terms together. So this will call this side, this will subtract this side. So we're going to have y 1 minus 4 is equal to y minus y over 2. So this will be negative 3 is equal to y minus y over 2. So you can solve this side alone if you want. The common denominator is 2. Here you can put a 1. 1 into 2 is 2. 2 times y is 2y. Minus 2 into 2 is 1. 1 times y is y. Then you cross multiply. So this by that one will be negative 6. 2y minus y is simply y. So what is the value of y? The value of y is negative 6. So this is how we solve this equation. So we end here for the indices. I'll give you homework, the same questions that I've done with you. I need you to do them. So this is 4 marks. So this is where indices and logarithms end.